Well, hey there, guys. Now, today we're going to have a look at domain and range, as well as a set and interval notation. All right, there's a little bit we're going to go through here, probably go for a few minutes. So make sure you get yourself comfortable, get a piece of paper and a pen, because I will press pause a couple of times, or get you to press pause a couple of times and attempt a few questions. So make sure you get all those things, and when you've got them, press play, and we'll continue on with the video. Excellent, guys. So let's now have a look at this presentation. So let's have a look first of all at interval notation. Now, when we're doing this, we're going to come across a whole bunch of things that are like dots, brackets, crocodiles, and even buzz. All right, so brace yourself, basically. So if we have a look here, let's have a look first of all at our symbols. Now, I refer to these as our crocodiles, and I'm sure you've probably heard of this before, where the crocodile always eats the larger number. And this will help you out a little bit as well. Now, there's a couple of things here that we need to know in terms of how to read this table. The column here is always known as the including one, so this means that they're including. This represents including such and such. And this one here represents not including. So when we're looking at symbols, or in other words, at set notation, it means that these ones here are including. So this one's less than or equal to, or including. And this one is greater than or equal to. And of course, not including just means this is less than or this is greater than. Okay, so let's have a look at how we can represent this on a number line. So it says illustrate the following number intervals on a number line. So therefore, -2 is less than or equal to x, which is less than or equal to 5. Or in other words, I just look at this as being x is greater than -2, or greater than or equal to -2, or less than or equal to 5. In other words, once again, x is between -2 and 5. So let's have a look at how we would actually plot this on a number line. Let's have a look. So you can see here that my x values range from -2 to 5, don't they? All right, that means if I come up here, yep, my x is there because the line represents x and the dots represent x. So if you go up here, well, x is between -2 and 5, as you can see. All right, let's have a look at this one now. And this is another way that we can see set notation, and that is in these brackets here, because of course the brackets, the squiggly brackets, means it's a set of numbers. And what the x means here is it's basically within this range. So any x value where x is greater than or just greater than -4 or less than -1. Now if we have a look here, it's already come up. So we can see that x values here are greater than -4 but less than -1. But let's now have a look at what you can see here. Now this obviously looks a little bit different to this, doesn't it? Now, the reason it looks different is because it's not actually including. If we have a look here, there's no less than or equal to sign or greater than or equal to sign. It's just saying x is greater than -4 but less than -1. So if we have a look here, the empty dots means that it's not actually inclusive. Now if I have a think about that, well, we know that x doesn't actually include -4 because it's greater than -4. So if we have a look up here, if I went from here straight up, well, it's kind of like there's nothing there, isn't it? I mean, I know you can see the outline, but really there's nothing there because it's an empty dot. So therefore x is not equal to -4, but anything greater than -4, it's equal to, of course, all out to -1. And once again, because it doesn't have an equal to sign underneath, therefore it's an empty dot once again. So let's have a look at this last one. It says x is greater than -7 but less than or equal to 3. So essentially x is between -7 and 3. But of course, what kind of dots are going to be at -7? Well, it's going to be an empty dot, and it's going to be a coloured in dot here at 3 because it's less than or equal to 3. So it's between -7 and 3. This one here is empty. This one here is, of course, coloured in. Alright, let's now have a look at the next type of way that we can represent interval notation, okay? Or set notation, and how we can represent domain, really, is what we would call it. Alright, now this one here is interval notation. You can see here, it's not like x is greater than or equal to. What we've got here is brackets, okay? And this actually represents a whole bunch of things as well. Now, including, if you see a square bracket, that means essentially the same as this crocodile kind of thing here with the equal to underneath, right? So square brackets mean including, and round brackets mean not including. So if we have a look at here, we're going to draw on the number line from -4 to 6, where -4 is included and 6 is included. Now, of course, if it's included, it is a coloured in dot, so let's do it. -4 to 6, both coloured in because it's both square brackets. Now let's have a look at 3 to 10. So our lowest value is 3. By the way, our lowest value will always go on the left and our highest value will always go on the right when writing it in these brackets as well. So 3 to 10, but of course the round brackets means not including. So a not including means it's going to be an empty dot. So let's have a look at this. 3 to 10, not including both of those because they're both round brackets like you can see, and therefore it's an empty dot, 3 to 10. Alright, and this one here, well, it's saying from negative 1 inclusive to 5 not included. So therefore a negative 1 will be a coloured in dot and 5 will be an empty dot. Excellent, so it's now time for you to press pause and attempt the following questions. That is, illustrate the following number intervals on a number line. That is from negative 6 to 8, where x is greater than or equal to 7 but less than or equal to 10, where x is greater than or equal to negative 9 but less than negative 2, and from 0 to 5. Now, of course, when you're done, press play so you can check your answers out against mine. Excellent, guys, so welcome back. Now let's have a look at this. Alright, so from negative 6 to 8. Now, because it's a round bracket, it means it's not including, doesn't it? So therefore it's going to be an empty dot at negative 6, and of course a filled in dot at 8. So let's have a look at that. Empty dot to filled in dot, and we just join the two dots there with a line. Alright, this one here, x is greater than or equal to 7, but less than or equal to 10, so therefore of course it's going to start at 7, go all the way to 10, and they're both going to be coloured in dots because you've got the equal to sign there. Now if we have a look at this one, x is greater than or equal to negative 9, but less than negative 2. So it's going to start at negative 9 with, of course, a coloured in dot, and it's going to go all the way to negative 2 with an empty dot. So let's have a look. Negative 9 to 2, coloured and empty. And this one, of course, from 0 to 5, both round brackets, so therefore they're both empty dots, 0 to 5. Excellent. So now let's have a look at it in the other way. All right. Obviously, we've been drawing along the number lines, but let's now have a look at how we would write these in set and interval notation. All right. Now, of course, we know that including means it's going to be a coloured in dot, and not including means it's an empty dot. So, of course, when you look at these, we'll know that these ones are including, and these ones here are not including. All right. So let's first of all look at this one here. For question A, describe the following subsets of the real numbers using interval and set notation. Well, let's have a look at interval first of all for this one. Interval is nice and easy. It's just the square brackets that we're talking about. So you've got from negative 4 to 3, and of course, because they're both included, it is a square bracket. Now, for the set notation, this is a little bit harder. This is how we write it out. We write for any x value in the set brackets, as you can see. Right, so any x value, x is greater than or equal to negative 4, but less than or equal to 3. Alright, so as you can see there, x is greater than or equal to negative 4, but less than or equal to 3. Alright, let's now have a look at this one. So interval notation, of course, is from 2 to 10, because you can see that I've got a square bracket at 2 because it's coloured in, and a round bracket at 10 because it's empty. And for this one at the set notation, once again, well, it's going to be greater than or equal to 2 because it's coloured in, but less than 10 because it's not coloured in. Right, let's have a look at this. In fact, what I might get you to do is I'll get you to press pause once again and attempt the last couple of questions. Now, the last one's going to be pretty hard, so we'll see how you go. But yeah, do press pause and attempt them now. And remember, when you're done, press play so you can check your answers out against mine once again. Excellent, guys. Welcome back once again. So let's have a look at this last one, two. So we've got here from negative 2 to 4. Not included here, obviously, and it's included here, so it's going to be a round bracket and a square bracket. So, of course, the interval notation is from negative 2 to 4, as you can see here, round bracket negative 2 because it's empty, and a square bracket at 4 because it's filled in. And then for set notation, well, it's going to be x is greater than negative 2, because, of course, it's larger than negative 2, but it's not included. And it's less than or equal to 4, so therefore, because it's less than or equal to 4, you go up here, you can actually see it's been coloured in, so it all works out. Now, this one here is a little bit harder. Let's see how you went. Let's have a look at the interval notation first of all. Now there's two lines here, isn't there? So let's have a look at how we can write that. And you'll actually, if you think about it, we've learned about this before. The interval notation is from negative 8 to negative 3. Now, of course, empty bracket here, or a round bracket, should I say, because it's an empty dot. So round bracket for empty dot from negative 8 to 3, which is included, so it's a square bracket. Union with, meaning as well as, from 1 to 9. And of course, they're both coloured in dots, so they're both square brackets. So the union with means we can join them up. Now for the set notation, well, this is a little bit harder again. You can see here for set notation it goes from negative 8 to 9. Well, let's have a look at that. Is that true? It goes from negative 8 to 9. Okay, that's kind of true, but not 100%, is it? Because you can see here negative 8, well, x is greater than negative 8, of course, not coloured in, so that's fine, I'm happy with that. And x is less than or equal to 9, of course, once again, happy with that because it's coloured in. But then there's this little section here that's not 100% correct, isn't there? So how are we going to do that? Well, what we do is we put in the excluding sign and then we say what has been excluded. Now the bit that's being excluded is anything between -3 and 1. But of course we don't want to make that the equal to here because we're excluding it, aren't we? So it means if we made that equal to, well, we'd also be excluding the -3. So we're just saying excluding anything between -3 and 1 that's not included. Alright, now of course if you do get stuck with this at any point, come and see me because this one's a little bit harder to get your head around. Now, let's have a look at the next section. So, infinity. This here is it's a big thing, and this is where Buzz comes into play, and hopefully you'll recognize this as well. So let's have a look at Buzz in action.
To infinity and beyond!
One of the best movies of all time. That's right, when I first heard Infinity, I was thinking Buzz Lightyear for the whole lesson. So, infinity essentially means that. To infinity and beyond means to keep going on and on and on and on and on and on. And it won't keep going on, but it keeps going on forever, if you get what I'm saying. So, infinity is to continue on forever, and it's represented by the following symbols. Okay? If you have a dot that goes on, and then the arrow means it goes on forever. It doesn't matter if it's a colored in dot or empty dot, that's showing where it starts, but the arrow means it goes on forever. Infinity is also represented by this little symbol here. Now it kind of looks like an 8 that's been turned on its side. And you can of course go down to negative infinity. And that would be represented by an arrow going in this direction, of course. Alright, and then the other way to do it is you would just have a 1 symbol. Whereas in the past you've had or in the beginning of this presentation you've seen 2 greater than or less than symbols. But this one here you just have 1 symbol saying that x is anything greater than 0. Meaning it would just continue on for any number greater than 0. Alright, let's have a look at this in action then. So it says illustrate the following in number intervals on a number line. So therefore x is less than or equal to 3. So of course it's going to start at 3, but the x values exist for anything less than or equal to 3. So it goes on forever down that way. So let's see how we make it look. Of course, coloured in dot, and then it goes on forever with the arrow as you can see. For this one here, we're drawing it from -5 to infinity. Now, of course, it's a round bracket at -5, right? So you can see here, -5. And by the way, infinity will always be given a round bracket because it's not an exact number, all right? Infinity, you can always think of a number bigger than the highest number you can think of, all right? You can always go that number plus 1, for example. So, because it's not an exact number, we actually represent it with a round bracket. Always has a round bracket. So, -5 to infinity means it's going to start off at -5, not included means it's an empty dot, and it's going to go all the way to infinity. And infinity is up this direction because it's positive, so it's going to start at -5, empty dot, and then the arrow continues up forever like so. Let's have a look at the last couple of questions. Describe the following subsets of the real numbers using interval and set notation. Right, let's have a look at this one first of all. So it starts, well, essentially starts at negative infinity and goes all the way to -3, doesn't it? So we can write that as being from negative infinity, remember, round bracket, to -3. Of course, square bracket because it's included. And then the set notation, well, that's just the same as saying any x value where x is less than or equal to -3, as you can see. Well, of course, x is less than or equal to -3. For this one here, interval notation is going to be negative infinity to -6. Of course, -6 is included. Union with 1 to infinity because 1 is included as well. And of course, once again, infinity has the round brackets. In set notation, well, I can actually write it like this. Or, sorry, in interval notation, I can also write it as any real number, excluding the numbers from -6 to 1. And of course, the bits that we're excluding, we don't want to exclude -6 and 1 because we want to include them. So therefore, you write that as a round bracket. Now, in set notation, what we do is we do this. We write any real value excluding from -6 to 1. And of course, we don't want to exclude the actual -6 and 1. So we just write it x is greater than -6 and x is less than 1. Alright, once again, if you do get stuck with any of these, they are a bit harder, especially when you've got the 2 dots or the little bit in the middle that you're missing out. Come and see me and I'm more than happy to help you out.